Hello YouTubers, Richard here. Welcome to episode 3 of my Engage Antics series of videos about using Arduinos with DCC model railways. In this episode I'm having a look at points control using servos and Arduinos as DCC accessory controllers. I'll run through the equipment I've got on the table in front of you. In the background we've got my first effort at an Engage model railway, and that's got the Prodigy Express DCC controller base station attached to the rails. We've got an old notebook running the JMRI software, and we've got the special cable to connect it to the base station. There's an iPhone running the Y throttle software, and then we've got my test rig of Arduinos, servos and some speakers and so on. I'm going to zoom in on that so that we can have a closer look at it. The power supply I'm using is something I found kicking around. I think it's made by Yamaha for some sort of musical instrument. It is rated at 11.5 volts, 600 milliamps DC. It actually produces about 15 volts. I've got 4 of those step-down transformers. They're configured to produce 3 volts. 2 of them produce 5 volts and another one produces 12 volts. These are optional. You can use a 9-volt power supply directly into the power connectors of the Arduinos. I've chosen to take this approach because I've got some other bits and bobs I'll be using later on which require 3 volts and 12 volts. The musical instrument power supply that I showed you is connected to the input of these step-down transformers. We've got an Arduino Uno, and we've got the DCC interfaces, DCC shield plugged into that. We've got an Arduino Mega, which is the slightly larger version which has more pins, and we've got a Adafruit servo shield connected to that. The next bit's optional. We've got an Adafruit sound effects module which has got a built-in 2-watt amplifier and a couple of appropriate 4 ohm 3-watt speakers, and I've connected 8 servos and screwed them to a bit of wood so they're easy to see. I feel that 8 points is probably a realistic maximum in a real world route, so providing we can get this to work reliably with 8, it should be good on real layouts. So the first thing I'll do is show you it in action. I've configured the points in JMRI and organised them into 2 routes, one called all thrown and one called all closed, and you can see those are available on the Y throttle screen on the iPhone. So if I click on all thrown, you'll see the servos all move into position. I'll repeat that by throwing the all closed route. A couple of things you might want to take note of: all of the servos are moving at the same speed, all of the servos are moving the same sweep, and servo 8 is configured to run in the opposite direction, and that's all done by configuring the software in the sketch that I've written to control these. So I'll just trigger them one more time. Now you can hear there's a sound effect going on in the background. I'm not yet happy with the sound effect. I can't find a sound effect of an opening or closing point, and I think that's actually a roller shutter door or something. It's too long, so it's only having time to play it 3 times for the 8-point movement, so that needs a bit of work, but the principle works. Probably the key element to this project is this DCC interface DCC shield. This is connected to the tracks, and it also uses power from the tracks to power the Uno, which is a nice feature. It's got all of the isolation technology built in so that the nasty rough signals from the DCC system are kept isolated from the Arduino. We're using this in conjunction with the Minor Bay DCC monitor software, which I'll show you in a moment. I'll explain how these things are connected together. If we start with the power, as I mentioned, we've got connections to the track coming into the DCC shield. That's stepped down and provides 5-volt power to the Uno underneath it, so you don't need separate power for that one. For the Mega here, I've got a 5-volt power supply being provided by one of these step-down transformers. The native voltage in is 5 volt for these Arduinos. Because the whole point is to separate these electromechanical devices, the servos, from the underlying Arduino, then I've got a second 5-volt power supply here which powers the servos. We've got the 2-wire I2C network between Arduinos connected with these yellow and orange wires, the SDS and SDL pins, so those go to the corresponding pins on the Mega. Although it's called a 2-wire network, it actually requires a 3rd wire because they have to share a common ground, so we've got a ground running between them with this wire. Then we've got another power supply of 5 volts going in to this amplifier there, and of course the speaker cable's coming out there. Now I'm not going to cover the soundboard in this episode, but this other wire is used to trigger the sound effect, so that connects the sound module to one of the pins on the Mega. I'm in danger of running up against my 15-minute limit for YouTube videos, so rather than get halfway through the description of the software, what I'm going to do is call this episode to a halt, and in the next episode, episode 4, we'll have a look at the software running on these 2 Arduinos. I hope you found this interesting, and I hope you'll join me in the next episode. Bye.